This is a lab problem from section 3.5. This is problem number 3. They want us to find the dy dx by implicit differentiation, and our implicit function or implicit equation is 7x to the third plus x squared times y minus y times x cubed, and that's equal to 9. So in this case we have a combination of some products and some chain rules. Well, implicit differentiation is always going to have a chain rule. So let's see how to find the derivative of this. We're going to look at this equation. We're going to differentiate both sides with respect to x. And so the derivative of the left-hand side is equal to the derivative of the right-hand side. It looks like the right-hand side is going to turn out to be an easy derivative because we're taking the derivative of 9. 9 is a constant. The derivative of a constant is 0. So that part is done. On the left-hand side, there are 3 terms, and we can work those out individually. The first term is 7x to the third power, so the derivative of that is 21x to the second power. 3 times 7, 21, x, and then subtract 1 from 3, so that's that. Now the next term is a product. Now y is a function of x, so we have to treat that as if there's something with an x in there. So we're going to have to look at the product rule. So the product rule, the first term times the derivative of the second plus the derivative of the first term times the second. So the first term is 2x, the derivative of that, or the first term is x squared, the derivative of that is 2x, and then the second function is y. So they gave us half of the product rule, we're just filling in the other half. And then that last one is similar, it's still a product rule. And so we're going to take a look at the first term times the derivative of the second term. So the derivative of the second term is going to be a 3y to the second power. So let's put 3y to the second power times, and they did this for us, but there should be a times the derivative of the inside of the function. So the inside function is y, the derivative of y is y prime, and they included that as part of our big derivative for us. So this is the first part of the product rule. The second part of the product rule, they took the second term here, and we just need to take the derivative of the first term, and that just happens to be 1. The derivative of x with respect to x is 1. So this is our third term on our left-hand side. So now we're going to put it all together. The derivative of 7x to the third is 21x squared. The derivative of this is 2x. Oh, they did this for us already. The derivative of the second term is this product, and then minus the derivative of this term is this product rule. So now we're going to rearrange it, and the way we're going to rearrange it is we want to collect all the terms with a y prime and bring that over to one side. So there's a couple of terms with y prime. So on they kept the non-y prime terms on the left side. So this is one of them. 2xy is another term that doesn't have a y prime. And then a minus y cubed is our other term that doesn't have a y prime. So what has a y prime? So the terms that have a y prime would be this negative 3xy squared times y prime, and then this is a plus positive x squared y prime. But we want to bring that over to the other side. So it looks like they got this covered. They got the plus x squared y prime brought over to the other side, so it becomes a negative x squared y prime. And then they have a y prime times something, so it must be this thing, y prime, this y prime times this something, negative on the other side. When we bring it over to the negative on the left-hand side, we bring it over to the right-hand side, it becomes a positive. So that's just a 3x times y to the second power. Now that we have everything that has a y prime on the left-hand side, we're going to factor that out. So we're going to factor out the y primes. Meanwhile, the left-hand side would still be this thing. And then after we factor out the right-hand side, we're going to divide out by that value, or by that factor. Actually, let's take our time here and actually see what's going on, just to be absolutely sure about what we're doing. So we have 21x squared plus 2xy minus y to the third power on one side, and on the other side we have a 3xy squared times y prime minus an x squared times y prime. So this is what we're working with at this point in our problem. And what we want to do is, on the left hand side, we want to factor out a y prime. So here's what I'm going to do. I'm just going to factor it out. So I take out that y prime and I take out this y prime, and then now it becomes this thing without the y primes because I had taken it out. Alright, so the only thing left to do is to divide by this this term, this 3x y squared minus x squared term. So if we divide that out, we're going to take this whole term and then put it as a fraction from here. So let me do this a little bit carefully. X divided by y. Alright, so I just wanted to set up a fraction. And now the bottom is this expression that we have that was multiplied by the x squared, or by the y prime term. And then the numerator stays the same. So we have the same numerator here. And then our denominator is this expression. Okay, so that's what y prime should equal to. So let's put that down here. Let's set up our fraction first, and then let's put our expression 21x squared plus 2xy minus y to the third power divided by this factor that we got on the left hand side with a y prime. So that's a 3xy squared minus x squared. Okay, so that should be it. Again, your y prime, from an implicit differentiation point of view, your y prime probably has a combination of x's and y's that you need to solve for. Okay, I hope that helps.